Hello everyone, I'm Jason Reichert.
I'm Patrick Hara.
I'm Alex Flair.
And we're Team E45, presenting the Vibrating Alert Bracelet. Personally, I worked on hardware, so we'll go through that first. The bracelet itself is based around an ESP8266 microcontroller. We chose this microcontroller for 3 specific reasons. The first one was that it's relatively low power consumption. The second is that it has integrated Wi-Fi, which is important because we need to communicate to a server in order to get alerts out. And it has a wealth of open source software that we had access to. We built a PCB. It's got 4 layers. It's pretty compact. It's 23.7 by 41.3 millimeters, so it fits in a bracelet form factor. There are a couple main components. There's the switch for user input. There's a bicolor LED. It does both red and green. And we have a pager motor and battery control. In order to increase the battery life of the bracelet further beyond what it normally would, we put it to sleep periodically. So we turn off the Wi-Fi radio and we just put it to sleep for a set amount of time. And this greatly improves the battery life. Over here on this graph, we can see that the baseline battery life is frankly pretty terrible because we're running with a really small lithium-ion cell. It's 290 milliamp hours, and when we don't do any optimization at all, we end up with about 3.5 hours of battery life. And if we increase the sleep time up to a minute, we're able to get almost a day's worth of battery life.
So as for the app side, you'll see this is the connected bracelet screen we have here, which lists all of the bracelets that the app is supposed to recognize. And then you'll note that Jason Reichert here is listed as green because his bracelet over there is currently connected to the server. Now, if I want to send a mass alert, I can hit this button and send an alert. This contacts the server and sets the alert state to high. You can also cancel the alert when you after that. Oh, there we go.
It works.
It certainly does. Anyway, so after the alert's done and you don't need it anymore, you can cancel it, and that'll stop all the subsequent check-ins from triggering alerts. Server-side software does a constant. It constantly just gets pulled and keeps a list of all the bracelets that are supposed to be connected to it. And as this dynamic list is updated and maintained with the different MAC addresses for the bracelets, it keeps an alert state for each of the bracelets from that side coming in, and then alert state for your whole system, like going out. Otherwise, it receives constant updates from the app, and then also the bracelets. Each of the bracelets, it knows which ones which ones it recognizes based on the MAC address of the ESP contacting it.
Bracelet works by connecting to a Wi-Fi network that the server is also connected to, and then frequently it will connect to the server and send a series of messages. The first message will identify the bracelet as a bracelet and not the app. The second message checks in and sends whether or not this button has been pushed. And then it will wait, it sends a MAC address after that to identify which bracelet and user is checking in on the server. And then the bracelet will receive a message from the server that will either say if there was an alert sent from the app, then will then buzz the pager motor in the bracelet, or it will just end the communication and disconnect, and then the bracelet will go to sleep.